Okay, today we're going to be talking about the layers of the atmosphere. Just remember while I'm going through these notes that you can pause it at any point or you can replay it if you need to a little more time than what I'm giving you to write down your notes or if you need to hear something again. Now we're going to be starting at the bottom and going up to the top because in the atmosphere, the layers start from the bottom where we are, where we live, and move up to the top where they kind of fade into space. So the bottom of your foldable is going to be the layer number 1, which is the troposphere. The most important part about this layer is that we live here. The weather occurs here. So all that rain and snow and all the clouds and wind, that all occurs within this layer. It doesn't go outside of this layer. At the top of this layer, it's about negative 60 degrees Celsius. Keep in mind that water freezes at 0 degrees Celsius. So this is a little bit colder than that. And that helps to keep all the water in this layer of the atmosphere rather than allowing it to drift out. The troposphere is between 9 and 16 kilometers thick. And 75% of the atmospheric molecules are found here. So what that means is all of the gases in the air that we breathe, 75% of those gases are in the troposphere, which leaves only 25% for all the rest of the layers. Our second layer is called the stratosphere. The stratosphere starts at the top of the troposphere and goes up to about 50 kilometers above the Earth's surface. The upper stratosphere, the top of the stratosphere, contains the ozone layer and is warmer than the lower part. So that's different than the troposphere, which is very cold at the top but warmer near the bottom. The ozone layer is what helps protect us from the harmful ultraviolet rays that the sun gives off. This layer contains about 24% of atmospheric molecules. So if you're doing the math, we had 75% in the troposphere and we have 24% in the stratosphere, which leaves us with about 1%. So there's not many molecules in our upper layers. Our third layer is the mesosphere. Meso means middle, just like the layers inside the Earth. The mesosphere was the middle layer. We have another mesosphere in the atmosphere. This layer starts at about 50 kilometers above the Earth's surface and ends at about 80 kilometers above. The outer mesosphere, the top part, is the coldest part of the entire atmosphere and is about negative 90 degrees Celsius. This is the layer that meteoroids burn up. A meteoroid is what you would often call a shooting star. So when you see a shooting star, it's still pretty cool to see, but it's not actually a star hurtling through space. It's just a piece of space rock that entered our atmosphere. And as it comes through the mesosphere, it's moving so fast that it actually burns up. And that flame, that shooting flame, is what you see and call a shooting star. Our next layer is called the thermosphere. The thermosphere starts at about 80 kilometers above the Earth's surface, and it just blends gradually into outer space. So it just kind of fades away into space. It can be up to 1800 degrees Celsius. And you may have noticed that by the name thermosphere. We've talked before about how the prefix thermo means heat. So the thermosphere is the hottest layer of the atmosphere. Now the thermosphere is made up of two parts. It's kind of separated into the ionosphere and the exosphere. Our next layer, 5, is the ionosphere. The ionosphere, as I said, is the lower layer of the thermosphere. It starts around 80 kilometers above the Earth's surface and goes all the way up to about 550 kilometers. The aurora borealis, which is also called the northern lights, occurs in this layer. Here are some pictures of the aurora borealis. These were taken by a friend of mine who was in Alaska for an extended time period, and they were able to get some of these neat pictures right outside their house. So it's just a really neat light show in the sky. Very rarely does it come down this far south, but every couple of years we are able to see it around here if the skies are clear and the conditions are just right. It's not nearly this cool though. All right, now that brings us to our last and final layer, the exosphere. So that's, as you probably guessed, the outermost layer of the thermosphere. It's the outermost layer of the entire atmosphere. The prefix X has to do with, leaving outside. An exit to a building takes you outside. The exosphere is the last sphere before you're outside of the atmosphere. It begins at about 550 kilometers and goes outward thousands of kilometers. It just kind of gradually fades into space. Now we're just going to flip over the organizer, and on the back, you're going to fill in the composition of the atmosphere. So here's the gases and things that make up the atmosphere. And you're probably thinking, I'm sure you know that there's oxygen in the atmosphere, and you know that we need that to survive. But you're probably going to be surprised that oxygen is not the number one gas. So nitrogen is actually the most prevalent gas in the atmosphere, coming in with 78%. That's a little more than 3/4 of the atmosphere is nitrogen. Oxygen does come in second place, though, at 21%. A gas called argon is the next at 0.9%. Other gases and things that aren't listed here, 0.07%. And lastly, carbon dioxide, 0.03%. And that might seem kind of strange to you because you're always hearing people talk about carbon dioxide and how bad it is and how we don't want it in the atmosphere. And there's really barely any in the atmosphere. However, it does affect things. All right, so that's it for the presentation.